In this lesson, it seemed like we covered a lot of different ideas, but what we essentially did was looked at the Pythagorean theorem and then applied the Pythagorean theorem to a handful of different contexts. So recall that the Pythagorean theorem says that if we have a right triangle with side lengths of a units and b units, with a hypotenuse that is c units long, then a squared plus b squared will be equal to c squared. This is a very powerful statement. It relates to the three side lengths of any right triangle. So anytime we have a right triangle, we can relate the side lengths using this equation. So let's look at a couple of contexts that we applied this in. So suppose we have 2 points in the coordinate plane. We'll say the coordinates are x1, y1 and x2, y2. If we want to know the distance between these 2 points, we can imagine drawing in a right triangle. So I'll just draw a right triangle in here. So we'll draw a horizontal leg, a vertical leg, and then I have hypotenuse between these 2 points. And we see we have a right triangle here, and the distance between the 2 points is the length of that hypotenuse. So we'll just call that the length of the hypotenuse d, which also represents the distance between the 2 points. So we can think about this horizontal leg. If we imagine changing from x1, y1 to x2, y2, then we have a change in x there and a change in y here. And the change in x and change in y represent the length of those 2 sides of the right triangle if we ignore the sign. So if we look at the change in x, that horizontal side length has a length of x2 minus x1. So this is like a delta x equals x2 minus x1, and delta y will be equal to y2 minus y1. And then in this case, we know that we should have, based on the Pythagorean theorem, we know that we should have delta x squared plus delta y squared equal to d squared. But in this case, we have delta x and delta y expressed in terms of x1, x2, y1, and y2. So we can take this equation and rewrite it as x2 minus x1, which is delta x. We square that plus y2 minus y1, which is delta y. We square that, and that's equal to d squared, which we can then rewrite that as d is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Now this looks kind of almost like a scary equation, but it just stems from the Pythagorean theorem and representing the lengths of this right triangle in terms of the coordinates of these 2 points. We should also point out that delta y and delta x could be negative, but when we square those values in this equation, everything turns positive, so we don't have to worry much about the sign there. Okay, let's look at another context. So suppose we have a circle centered at the point HK and a radius that is r units long. If we have any point xy that's on this circle, then we can express those coordinates in terms of the center of the circle and the radius of the circle. So we can relate all of these things and write an equation for this circle. So again, let's draw a right triangle. So the hypotenuse will be from that center of the circle to that point we're looking at, horizontal side there, and we have a vertical side here, so we end up having a right triangle. Hypotenuse is r units long, and if we wanted to compute the length of this horizontal side, that has a length of x minus h. Again, that's like a change in x from h to x. The vertical side has a length of y minus k. Again, that's like a change in y if we vary from k to y. And therefore, we should have x minus h squared plus y minus k squared is equal to r squared. So again, we just draw a right triangle, we represent the lengths of the sides of the right triangle, and then we can relate all of the lengths of the sides of the right triangle using the Pythagorean theorem. And this gives us an equation for a circle centered anywhere and having a specific radius. Let's look at one last application here. So we had this Pythagorean identity, which is pretty important in mathematics. So if we have an angle with a measure of theta radians a radius of 1 radius length, then we can draw a right triangle in here. And the hypotenuse is 1 hypotenuse length long. X is going to be equal to cosine of theta, hypotenuse lengths. Y will be equal to sine of theta, hypotenuse lengths. And then the Pythagorean theorem tells us that x squared plus y squared is equal to 1 squared, which is just equal to 1. And then we can replace x and y with cosine of theta and sine of theta. And therefore, cosine of theta squared plus sine of theta squared is equal to 1. And this right here is what we call the Pythagorean identity. We also saw that sometimes in math we like to be more efficient with our writing, so we can write less characters or symbols. Therefore, it's common to see this written as something like cosine squared of theta plus sine squared of theta is equal to 1. Sometimes we even omit those extra parentheses out of there.